IT2103 Mathematics for Computing. This course consists of several chapters, and today we discuss first chapter of this course, which is indices and logarithms. And let's look at the indices first. Let A be any number and n a positive number. A product of n with itself n times can be written as a raised to the power n. The term n here is called index and the term a is called base. So, under these sections we are dealing with manipulating of a term like this. To manipulate the term like this, there are few rules. Let a positive number and mn be any number. The first rule of the indices is called can be written as a to the power m times a to the power n equal a to the power m plus n, where when we multiply the two terms like this, we just add up the indices. In dividing indices, we just subtract the indices. The power of the nth power of a to the power m can be written as a to the power multiplication of m and n. A to the power 1 is equal a and a to the power 0 is equal 1. So, let us verify these rules by taking some example. 2 to the power 2 times 2 to the power 3 can be rewritten by using the definition of indices like 2 multiply by itself 2 times and 2 multiply by itself 3 times, which can be simplified to 2 to the power 5. So, which is equal to 2 to the power summation of these two indices. In dividing, the 3 to the power 5 divided by 3 to the power 2 can be written as product of 3 with itself 5 times divided by product of 3 with itself 2 times, which can be simplified to product of 3 with itself 3 times, which is equal to 3 to the power 3. So, it's verified that this is equal the subtraction of indices. And 2 to the power 3 to the power 2 in the definition of indices, which is equal to product of 2 to the power 3 with itself 2 times. So, each term is expanded like this, product of 2 with itself 3 times. So, which simplify to 2 to the power 6, and it is verified it is equal to product of these two indices. Consider this example: a to the power n plus 1 divided by a to the power n by using the second rule of indices can be simplified into a to the power 1 as shown here. And also the same term, same expression can be reorganized like this: product of a m with itself n plus 1 times, product of a with itself n times, which simplify to a. And by comparing these two terms, you can see that these two terms must be equal, because these two represent the same terms, which give a to the power 1 equal a, which verify the fourth rules of the indices. Now, consider a to the power n multiplied by a to the power 0, which is equal to a to the power n plus 1 by applying the first rule of the indices, which give a to the power n. And also you know, by using the simple algebra, which is also equal to a to the power n times 1. and this shows that a to the power 0 must be equal to 1, which verify the last rules of the indices. Now, so far we have seen the positive powers of the positive indices. Now, let us look at the interpretation or explanation of negative indices. Look at this example. As you know, a to the power 2 divided by a to the power 5 can be written as this: product of a with itself 2 times divided by product of a with itself 5 times, which simplify finally to a to the power 1 over a to the power 3. And by using the one of the rules of the indices, that also can be simplified to a to the power minus 3. So, by comparing these two terms, you realize that a to the power minus 3 is exactly equal to 1 upon a to the power 3. That is this. So, now you have that you can understand that the negative, the a to the power minus 3, the negative indices can be interpreted or can be transformed to the positive integers like these expressions. So, this can be generalized to this a to the power minus n equal 1 upon a to the power n for any n. Right. So far we discussed the indices which are integers. Now, let us see the meaning of fractional indices. Let's look at this. What is the square root of a? What do you mean by the square root of a? The square root of a is a number multiplied by itself gives the a. So, let us denote that as this. So, by definition of the square root, when you multiply the square root of a by itself, it should give the number a. And also, let us consider the product of these two terms, a to the power 1 upon 2 times a to the power 1 upon 2. By using the first rule of the indices, you can simplify that to a to the power summation of these two indices, which resulted a to the power 1 and which is equal to a. So, by comparing these two, you realize that these two terms must be equal, because the multiplication of these two terms equal to a and multiplication of these two terms is also equal to a. So, therefore, these two expressions must be the same. That is this. So, we can conclude here that a to the power half is actually the square root of a. So, now you understand the special fraction here, the special fraction 1 upon 2 is really means the square root. So, similarly, we can interpret a to the power 1 upon 3. So, which is the third root of a and also called cube root of a. So, we can generalize that the nth root, the a to the power 1 upon n is nth root of a. Right. So, now look at now we have looked at the special type of fraction, that is 1 to the power n. Now, to generalize this to any fraction, now consider again the nth root of a. By definition of the nth root of a, we can write this expression, that is, if you multiply the nth root of a n times, it should give a. So, this can be by using the definition of indices. So, this can be written as this, the a to the power 1 upon n to the power n. So, which can be simplified into this. So, now consider the general expression, general fraction like this, p over q. Now, we will see what is the meaning of a to the power p over q. As I explained earlier in the previous slide, this one, so this expression the product of a to the power p upon q, q times can be written like this, a to the power p upon q to the power q. So, which is equal, as you know, a to the power p. So, what this tells us? It tells us really this a to the power p over q is the qth root of a to the power p. Note that again a to the power p upon q can be reorganized using simple algebra like this. So, this is also equal to a to the power 1 upon q times p, and using one of the rules in the indices, which also can be simplified to a to the power 1 upon q to the power p. And look at this expression, this also tells, so a to the power p upon q is the qth root of a multiplied by itself p times. Example, let us see how we apply these to simplify some expressions. Look at this expression. So, when we simplify this, we should understand that this means the fourth root of x to the power 3, and this is the fifth root of x to the power 6. So, by using that understanding, we can simplify first to this one, and then applying the third rule of indices, we can simplify this further into this, and which give the results x to the power half times x to the power half. So, which is equal to x. Now, let us move to the logarithms. Suppose that a and y are positive real numbers, two positive real numbers, and if y can be written as a to the power x, if we can find a x so that y is equal to a to the power x, then we say that x is the logarithm of y to the base a. Example, so since 8 can be written as 2 to the power 3, the 3 is the logarithm of 8 to the base 2, that is this. And here, since 2 can be written as 4 to the power half, the half should be the logarithm of 2 to the base 4. And here, since 5 to the power minus 1 can be written as 1 upon 5, the minus 1 should be the logarithm of 1 upon 5 to the base 5. Right. Now, look at, to deal with manipulation of this kind of expression, there are few rules. Let us see those rules. Let a, x, y be 3 positive real numbers and k be any number. And there are 5 rules. The first one, the logarithm of multiplication of two numbers is equal to the summation of logarithm of each number. And the second rule says the logarithm of x divided by y can be expanded to logarithm of x minus logarithm of y. So, this tells us how you expand, how you get the logarithm of x to the power something, that is log of x to the power k is equal k times log to the log of x. And also there are some some facts that logarithm of a to the same base is equal to 1, and logarithm of 1 with any base is equal to 0. Now, see some example of applying those rules. Let us see how we simplify this one. So, this says to sum up logarithm of 20 to the base 5 to the logarithm of 1 upon 4 to the base 5. So, by using the first rule of logarithm, we can simplify that to this is equal to log of multiplication of these two terms, which is equal to log 5 of 5. So, using another rule of logarithm, which is equal to 1. And here when you subtract two logs terms, and you can simplify that to logarithm of the division of these two terms, 45 divided by 5, which is equal to log of 9 to the base 3, and which gives 2. Look at this one. The logarithm of 9 to the base 81 can be expressed as logarithm of 81 root of 81. So, which is also equal to 81 to the power half. The root of 81 means 81 to the power 1 upon 2. So, by using the definition of logarithm, one of the rules of the logarithm, we can take this power out. So, which is equal half log 81 to the base 81. So, which is equal to half. Right. Now, so far we deal with how to manipulate the logarithm terms. Sometimes you need to change the base of the logarithms. Now, this will tell the rules how to change the base if it is required. The logarithm of c to the base a can be written as multiplication of two terms, that is logarithm of b to the base a and logarithm of c to the base b. By applying simple arithmetic, we can reorganize this term to logarithm of c to the base b as the division of logarithm of c to the base a, logarithm of b to the base a. Now, you see this term is with the base b, and these two terms is in the base a. So, that is how you change the bases. Now, see the application of this rules to manipulate some example. Look at this example. Log of 3 to the base 10 is given, and the log of 7 to the base 10 is also given. Now, you are required to find log of 7 to the base 3. So, which is equal, which can be written as with a different base. Now, we should realize that to find the value of this using these two, we need to change the base 3 to 10. So, we change first. Logarithm of 7 to the base 3 can be written as logarithm of 7 to the base 10 divided by logarithm of 3 to the base 10. By replacing values for these two, it gives the final value. Let us look at another example. So, logarithm of 5 to the base 10 is given. What is the logarithm of 5 to the base 2? So, again we realize that we need to change this base to 10. So, when we change, it gives logarithm of 5 to the base 2 is equal to logarithm of 5 to the base 10 divided by logarithm of 2 to the base 10. Now, here we need two values for these two, but it is given only the value for logarithm of 5 to the base 10. How we find this one? So, we need to apply some method. We have to use some method to find this one. So, look at the technique that I am using to find logarithm of 2 to the base 10. So, this can be written, logarithm of 2 to the base 10 can be written as logarithm of 10 over 5 to the base 10, which can be expanded by using a rule of a logarithm like this, logarithm of 10 minus logarithm of 5. Since logarithm of 10 to the base 10 is equal to 1, we can find the value for logarithm of 2 to the base 10, which is equal to this one. So, now we can replace these values here. So, logarithm of 5 over 2 is given when we substitute the value here. So, which is equal to this. Thank you very much.